Hello and welcome to another Generative Components tutorial. Today we're going to utilize Generative Components to generate a simple maths test. If you have young children in your family, probably try to write one of these to help them with their studies. I was faced with the same problem, so I decided to automate the creation of 50 tests using a simple GC script. This will contain some simple addition and subtraction questions formatted into a grid of boxes. So let's get started. Starting with a new file called simple_math_test.dgn, I will set the main view to the top view and wireframe. Then I'm going to turn off the grid. Selecting the Home tab on the computational design workflow, I will check on the coordinate system icon to generate a base CS by clicking on Yes and OK. Next, I'll drag a point node into the graph. For the X translation, let's use a series by typing series, open brackets, 0, 200, 50, and then close brackets, which will provide a range of 200 millimeters, placing a point every 50 millimeters. For the Y translation, let's use another series with series, open brackets, 0, 275, 25, then close brackets. A range of 275, placing a point of every 25 millimeters. Zooming in, you can see we have a diagonal line of points. Right-clicking on point 1, we can select Switch Replication Style, and now you can see we have all combinations and a grid of points. Dragging in a polygon node and changing its method to by point grid, we can link this up to the point 1 node. Now we have our grid of polygons, we can select the point 1 node, right-click, and turn off its visibility. I will also turn off the visibility of the base CS. Next, we'll drag in a function call node, clicking on the 3 horizontal lines to create a custom function by selecting Yes. This opens up the editor, and for now, I'll just remove everything so we can start from a blank function. Starting with the word function, and then open brackets, we can set up the variables we might need for this function. Most will be integers or full numbers, so we can start with int, and then I'm going to call this min number 1, being the minimum value of our first number. We can then place a comma and use another int and call it max number 1, and then a comma, int min number 2, comma, int max number 2. This will set the range of our two numbers we wish to add or subtract. Finally, we can include a polygon input, which can be called input boxes, and then we can close brackets. Placing 2 curly brackets to contain our function, we can give ourselves some room to write our function. Our math test will be created using text nodes, so the output for this function is going to be a string. So let's start by setting up that output. And we can call that string myTextArray equals open and close curly brackets and then a semicolon. Now we need to start a loop. Typing 4 and tapping tab a couple of times, this will complete the line for us. Changing the count to inputboxes.count with a capital C. Inside this loop, we can set up another container for the lists. So I'm going to call this string myTextList equals open and close curly brackets and then a semicolon. As we have an array of polygons as our counter, we need to have a second loop to access those individual polygons. So we can do that again by typing 4 and tapping tab a couple of times to complete the line. And this time we can change the first I over to J and then press a tab, and that'll change the others over for us. The count for this loop will be input boxes, open square brackets, I, and then close square brackets, dot count with a capital C. Inside this loop, we can start our math setup. First, let's set up an operator. This will be a string, and so we'll call it string myOperator equals, inside inverted commas, a plus sign with a couple of spaces either side, and then semicolon. We place the plus sign inside inverted commas as we essentially are building a text string rather than actually performing the maths operation. Next, let's create two numbers we wish to add and subtract from. And these will be ints, so we can actually call it int and then number 1 equals random and open brackets, min number 1, comma, max number 1, close brackets, and then a semicolon. This will simply select a random number between the minimum and maximum numbers we might input. And we can do the same for the number 2 input. So int number 2 equals random, open brackets, min number 2, comma, max number 2, close brackets, and then a semicolon. So far we have some numbers and a single operator, but we would like to have either a positive or negative, so either a plus or a minus operator. So let's set up a way of randomly selecting that. I thought this could be decided by a random number between 1 and 100, and then determining whether that was odd or even. This gives a different result than just selecting a 50-50 split between a plus or a minus, or maybe it doesn't. That could probably be another probability experiment on its own. We can start with int myRandom equals random, and then open brackets 1, 100, and then close brackets, and then a semicolon. To select the operator, we can use an if statement. So we go if, open brackets, myRandom, and then %2 is greater than 0, and then close brackets. So if we divide the number by 2, does it have a remainder? And if it does, then we want to do something about it. So then we can open and close curly brackets for the if statement. And then within this if statement, we can simply set myOperator equals, in inverted commas, just the minus sign. And then we can put a semicolon. Now generally that would work okay, but what if the numbers ended up being a negative result? We probably want to avoid that for the younger viewers. So let's set up a new if statement inside this if statement, and we can do some other maths. So if, and then number 1 minus number 2, if that is less than 0, then we might want to address that. So we can open and close curly brackets again, and then inside this one we can actually say my operator equals plus inside inverted commas. Now it's just a matter of building up our string. First we need to convert those numbers into strings themselves. So first we go string, my number 1 equals toString, open brackets, number 1, close brackets, and then semicolon. And we can do the same for the number 2. Finally, we can put together the pieces. So string my maths equals my number 1 plus my operator plus my number 2 plus and inverted commas equals. So what that does is just concatenates those things together in a text string. Then we can place this all into our list. So my text list.add, open brackets, my maths, close brackets, and then a semicolon. And then in the outer loop, we can place this list into the array. So my text array.add, open brackets, my text list, close brackets, and then semicolon. Finally, we can return that array. So return my text array and then semicolon. We can click apply and close this window. Now you can see all those inputs we set up. So let's fill those out with some initial values. I'm going to set min number 1 to 1, max number 1 to 20, min number 2 to 1, max number 2 to 20. And for the input boxes, we can link that up to polygon 1. If we click on the plus sign to expand the dialog, we can now see we have an array of strings that are simple maths questions. So let's rename this node to mymath. Now we can drag in a text style node and change the width and height to 5, set the X offset to -20. And here we can also click on the drop down arrow and set up the font. Next, let's drag in a point and setting this method to centroid of set. The input for this will be polygon1.vertices. And with that complete, you can see there's now a point generated at the center of each of the polygons. So dragging in a text node, we can link the placement up to point 2 node. If we click on the drop down, we can pin out the text style input. Now we can link up the text style 1 to the text style input. And I've linked up the wrong thing here, but it's an easy change by right clicking, selecting disconnect from text value, and then link it up to the correct input. Now we can link up the mymath node to the text value. You can see the text is huge. If we switch over to the building design or type in the annotation scale in the top search bar, the properties dialog will appear where we can change the annotation scale from 1 to 100 to 1 to 1. And you can see this doesn't work. In the bottom dialog you can see a note, change rejected in order to preserve design integrity. So the solution to this is to head over to the transactions tab, and to make it a bit easier to read, I'll right click and select rebuild transactions. Now what we can do is rewind those transactions back to the first entry, and then we can change that annotation scale without any issues. Replaying all those transactions by clicking on the last transaction, you can now see the text is the correct size. However, it's the wrong value. All we need to do is change that text value input by adding a dot value after the mymath. Now you can see we have a simple maths test. Now we could easily just print this out, but maybe we'd like to create 50 of them. And I don't like the idea of doing that manually, so let's automate that. So let's drag in an export node. The nodes to export we can link up to polygon 1 and the text node. So now for the output, let's put in inverted commas mymathssheet.dgn. There's no need for a path if you'd like it saved in the same location as your GC file. And for the seed file, I created a new file called math0_2d.dgn, and we put that inside inverted commas as well. If we open up that file, it looks like this. It's a simple file with an A4 sheet boundary, and I offset that slightly from the origin about 5mm in X and 10mm in Y. So our maths test will be centered on this sheet. So heading back to our GC, we can now click on export to ensure this updates and open the My Maths sheet to confirm we can see the maths test is positioned correctly. So now let's create 50 of them. In the transactions window, let's right click and select add script transaction. The editor will open and we can change the name of the transaction to generate test. Now we can place a for loop by typing the word for and tapping tab a couple of times to complete the row. And for the count, I'm going to set this to 50. We are now going to need a string for the new file names for each of the files we're going to generate. So let's build that up by typing string my file name equals in inverted commas math plus toString and then open and close brackets and inside put I plus and then inverted commas .dgn. So this will take the math and then add whatever integer we're up to in the loop. So math 0 through to math 49. Next, we'd like this to be inserted into the export node. So we can do that with the line export1.export design file equals my file name and then semicolon. The last step is to update the script to generate the unique tests. So then we input the line update GC model and then open and close brackets and then a semicolon. We can then click apply and close this window. You can see this new transaction is not green as we've not run the transaction yet. We can click Save to ensure everything is updated, and then let's click on that transaction to run it. And with a little bit of movie magic, you can see the numbers changing in the background, and it's generating the 50 files. And here are the results, 50 maths tests ready to print. I then just used the print organizer and printed them out into a single PDF. Job done. This is a very simple example of utilising GC to do something out of the ordinary, but there are some great methods here that can be applied to everyday design problems. Hopefully you'll find a way to incorporate some of these concepts into your next project. Until next time, thanks for watching.